All right, let's dive into one of programming's most famous and, let's be honest, most controversial design patterns, the Singleton. It's a pattern that promises you absolute control. But as we're about to find out, that control can come at a really steep price. So let's get right into it.
So to really get a feel for why this pattern even exists, let's kick things off with a little thought experiment. This is a great analogy from the Sweet Cody channel. Just picture a super busy airport, right? You've got planes landing, taking off, taxiing all over the place. Now, what do you think would happen if you suddenly had two air traffic control towers both barking out orders for the same runway?
Yeah, it would be an absolute recipe for disaster, total chaos. You'd have conflicting instructions, planes getting dangerous orders. It's a mess. It's pretty clear that for a system like that to work safely, you need one and only one source of truth, one point of control. And that's precisely the kind of problem the Singleton pattern was invented to solve inside our applications.
So that leads us right into our first big idea here, understanding the problem that creates this chaos of many.
You see, just like that airport, some parts of our code really need to have a single authority. You know, things like a configuration manager for your entire app, or maybe the one connection to your database. If you start creating multiple instances of these things, well, you get the software equivalent of chaos on the tarmac. They start fighting with each other, overwriting data, wasting resources, and creating these bizarre bugs that are an absolute nightmare to track down.
Okay, so how do we actually enforce this one and only one rule in our code? Well, that brings us to the hero of our story, the idea of having one instance to rule them all.
So what is a singleton exactly? Well, refactoring.guru puts it perfectly. It's a design pattern where a class makes sure it has only one instance of itself, ever. And it provides one single global way to get to that instance. Basically, its entire job is to be a gatekeeper. No matter how many times you knock on the door asking for a new object, it always hands you back the exact same one. The class itself becomes the bouncer, making sure no duplicates get created.
All right, now for the fun part, coding the singleton. How does this actually work under the hood? Let's look at a really common way to build this in Python. And the key is, we're going to focus on a special method that gets involved before an object is even born.
Okay, so most of us are familiar with the init method in Python, right? That's what runs after an object has already been created to set it up. But the Singleton pattern uses a clever little trick. It hijacks the process before that, using a different magic method called __new. This is the method that actually creates the object. So by overwriting it, we can step in and take control. The logic is simple. We have a class variable, let's call it _instance, that starts as none. When someone asks for a new object, __new checks that variable. Is it none? If yes, great. We create the object for the first time and save it in _instance. Then, from that point on, if anyone else asks, we just return the object we already have stored. We completely bypass the creation step.
So let's walk through it. The very first time our code says tower1 equals control tower, the __new method wakes up. It checks its little storage spot, sees it's empty, and says, all right, let's make one. It creates the object and tucks it away for later.
Then, a little later, maybe somewhere else in the code, we ask for another one. Tower2 equals control tower. The __new method kicks in again. But this time, when it checks its storage, it says, whoa, hold on, I've already got one of these. And instead of making a new one, it just hands back the exact same one it made before.
And here's the proof. If you actually check if tower1 is the same object as tower2, Python will tell you true. And that doesn't just mean they have the same values. It means they are literally the exact same object sitting in the same spot in your computer's memory. And just like that, we've guaranteed our single point of control.
So this isn't just some abstract theoretical idea. The singleton pattern shows up to solve real problems. Let's take a look at the singleton in the wild.
Okay, so where would you actually use this? Well, you'll typically see singletons pop up for things that are expensive to create, or for things that absolutely have to be consistent across your entire application. Think about a database connection pool. You definitely don't want every single part of your app opening up its own separate connection. That's a great way to crash your database. The same logic applies to things like logging services. You want everything writing to the same log file, or a single object that manages all your app's configuration settings, or even controlling access to a single piece of hardware, like a printer.
But, and this is a huge but, the singleton has a dark side.
There's a reason so many experienced developers get a little nervous when they see one. It's a powerful tool for sure, but it can also be a dangerous one.
In fact, as refactoring.guru points out, a lot of developers today actually consider the singleton an anti-pattern. And what does that mean? It's a pattern that looks like a good idea on the surface, but it often ends up causing more problems than it solves. It's a solution that can be, well, counterproductive in the long run.
And this really gets to the heart of the debate. On one hand, you have the promise. You're guaranteed to have a single instance, a global access point, a single source of truth. It sounds great, but then you look at the peril. It basically acts like a global variable, which can be modified from anywhere, making your code super unpredictable. It also hides the dependencies of your classes. And testing? Oh, it makes testing a total nightmare, because you can't just create a fresh, clean version for each test. And that's not even mentioning the headaches it can cause in multi-threaded code.
And here's another subtle problem, which Portfolio Courses brings up. That clever_new method we looked at, it's too clever. Another developer might come along, see the line, control tower, and have no idea they're not getting a new object. They're unknowingly messing with a shared global state, which can lead to all sorts of confusion. Some other implementations use a more explicit get_instance method, which is a bit clearer, but the core issue remains. Singletons can hide what's really going on.
Ultimately, it's a trade-off between strict control and your code's flexibility. The singleton pattern gives you absolute power over an object's lifecycle, ensuring there is only one. But that power comes at a steep cost to your code's modularity, its testability, and its clarity. So before you reach for this pattern, you have to ask yourself the question we're left with here. Is the problem you're solving so critical that it's worth that price?